Hello Math 7 students, this is Utah Middle School Math Project 5.3b, Area of a Circle. This is part 2 and this should finish up this lesson. To get started, your homework over the weekend was to memorize the area of a circle, the formula that we use to find the area of a circle. So your warm-up is, in your calculator, type in the formula for the area of a circle. Students watching this at home, write it down. Test yourself out. Don't look it up. See if you can remember it. See if you follow the directions for your homework. We'll pause the recording. We'll go over this together in a second. Most students did okay on this. The formula for the area of a circle, what you should have typed in, is not just that pi r squared, but a equals, the area is equal to, remember, we had our radius squares, and we had a little bit more than 3 of those. So r squared times pi, or pi r squared. This is different, folks. This is different than the area, this is different than the circumference of a circle. The circumference of a circle is the circumference is equal to the radius times 2 times pi. Will you please take a second and discuss with your groups what is that difference here between these two formulas? They both have an r, they both have a 2, and they both have a pi. So what is it that is different between those? Talk with your groups. Ready, set, go. Okay, and now come back to me. What are some thoughts that you discussed or that you heard discussed at your own tables? Dylan. Yes. This is a power of 2, an exponent of 2, where here the radius is just being doubled. When we have an exponent of 2, some interesting things happen, and you can kind of see it here. Again, we call these radius squares, right? It's a radius times a radius, forming a radius square. When we're finding the area, we're finding it in square units. When we are finding the circumference, we are finding it in linear units, like a radius, and then it would be another radius to continue going around and another radius to continue going around. So it's linear measurements. We're not talking about square measurements. And so that not only changes how we calculate, it also changes the units of measure that we're going to be dealing with. So when I find the area, whatever it is going to be in units squared. Where when I find the circumference, it is just going to be in linear units or units. So that is something else that differentiates those two formulas. Other things to make note of, circumference can be written in terms of the radius, but circumference can also be written in terms of the diameter. The diameter multiplied by pi. Because the radius multiplied by 2 is the diameter. Can we do the same thing here with the area? Talk with your groups. Can we write the area in terms of the diameter instead of the radius? Talk with your groups. Ready, set, go. Okay, and now back to me. What are your thoughts? Could we write it in terms of the diameter instead? Grant. Yeah, not as nice and friendly, but ultimately we could. What we need to understand is a radius is really truly, let me move this up so I have space to write. A radius is really a diameter that's been divided by 2. So instead of radius, I could use diameter divided by 2, and then raise that to the power of 2, and then multiply it by pi. So is there a way I could do it? Yeah. Just not nearly as friendly and easy to remember as simply the radius squared multiplied by pi. So there is a way. I think it's better to just understand that relationship between radius and diameter. Okay, now finishing up where we left off, 5.3b, after all of this work, remember this activity here where we had our radius squares. We used technology to kind of move those radiuses, or the circle parts that we shaded in around, to see that it was 3 radius squares and a little bit more, which we recognized that was pi. We also did this fun activity where we cut apart a circle. We kind of reformed it to be this parallelogram shape, and then we looked at these images where if that circle was cut into smaller and smaller pieces, or more equal slices and reformed, it eventually really truly starts looking a lot like a rectangle. And so we were able to find this when we reshape this circle and kind of format it like a rectangle. We can see that it's really just the height times the base, where the height is the radius and the base is half of the circumference, and that is how we were able to arrive at our formula. A is equal to pi r squared. So let's put that to practice. Calculate the area of each circle. Express your answer both exactly, that means in terms of pi, and approximately to the nearest tenth of a unit. I will do the first one with you so that you can see what it is that I'm talking about when I say approximately and exactly. Here we have a measurement that is marked, and that measurement that is marked is the radius. It says 3.5 feet. Well, what do I do? First, let's get in the habit of writing down our formulas. Area is equal to the radius squared, which is then multiplied by pi. Here's our radius. So I'm going to take that radius, which is 3.5. Remember, our calculators don't handle those mixed numbers very well, so I'm converting it to a decimal. 3.5, and 3.5 is raised to the power of 2. So 3.5 squared, which is then multiplied by pi. Now, when it says answer exactly in terms of pi, that means I'm going to type everything else into my calculator except the pi. Because as soon as I type in the pi, it turns it into this big, long, ugly decimal because pi is irrational. And so all I'm going to type into the calculator right now is this 3.5 squared. Do that with me now. .5. For those of you who didn't get the warm-up correct, you probably maybe need some help finding some buttons. A couple things that you can do. You can go to your template button, which is next to the number 9, where you will see the exponent box. That's one way that you can do that. Another way that you can do that, there is a shortcut for just squared. If the exponent you need is a 2, next to the number 4 it says x squared, and it will take whatever you have and it will raise it to the second power. That's another option. And the final option is if you use caret. Next to the 4 is the x squared, and next to that is the caret. If you do that, that will create that exponent box so that you can put it as any exponent that you want it to be. We're only going to deal with exponent of 2 for right now. Maybe in the future in a different unit we'll be dealing with other exponents, but caret is probably too many extra steps. You're probably fine to just go 3.5 and then click that x squared button to square it. Type that in, press enter, and it will tell us that that is 12.25. So that means the area exactly, meaning still in terms of pi, would be exactly this. A is equal to 12.25 pi. The units of measure were feet, and so as I mentioned in our warm-up, that's going to be then feet squared. They're square units of measurement. It's just like drawing all of these square units on the inside to see how many of those it's going to take to fill that up. Okay. Now, it also wants us to do that approximately, and so when I do this approximately, maybe write yourself a note that this is exact in terms of pi. Approximately means we're going to type it all into the calculator. Which means we already know that 3.5 squared is 12.25. So just picking up where we left off, we can then multiply that by pi. And there is our decimal, or our decimal version, approximate. Does it say what we need to round to? Nearest tenth of a unit. So we get 38.4845. I'm going to write all of that down so you can see the rounding. .4845. So when I'm asked to round to the nearest tenth of a unit, that means I need the 4, but I look to the hundredths place, the 8, and I can see that that 8 is going to make that round up to a 5. So this is going to be 38.5 feet squared. We have our approximate, and we have our exact in terms of pi. Practice first with this one. After you do this one, then see how we can manipulate the strategy we've used so far to figure out the area of this circle. But skip ahead to this one. I'm going to pause the recording as students work with their groups. Ready, set, go. Okay, help me find the area of this circle here. What is that going to look like? What do I do? Davin? Why am I doing 5 squared? Great. Radius squared times pi, and we see here that this 5 is the radius. So that's why we're doing 5 squared, because 5 is the radius, and the radius is supposed to be squared. 5 squared, which is then multiplied by pi. What does that mean? What is going to be my exact answer in terms of pi? Yeah, 25 pi. All I'm doing is taking care of the 5 squared. 5 squared is 25, and that's 25 multiplied by pi. That keeps it exact. It still is equivalent to when I do this calculation, but this is exact where there's no rounding, no decimals needed. Let's not forget the units. This was miles, so 25 pi miles squared, or square miles. How do I find the area? Approximated. Let's move on to someone else. Thank you for helping me out with that, Devin. What is the area approximated? Joshua. 78.5. What did you do to get that? Yep, and 25 times pi. This is where we have to use our calculator. 78.539, which is rounded to the nearest tenth, and that is how Joshua got 78.5. That 3 is not enough to make it round up, so approximated, we end up with 78.5. Still, don't forget your units. That would be miles squared. I guess I probably don't need a plotted box around that. And the last one, we need to change our strategy a little bit. What do I need to do different for this problem? Carter? Exactly. We need to recognize that in this problem I didn't give you the radius like I did on the others. I gave you the diameter. So the diameter is 2.4. Instead, we need the radius because that is how the formula for area is written, is in terms of radius. So the diameter is going to be divided by 2, and we get 1.2 inches for the radius. Now that I have the radius, what is my next step? Alexis. Why 1.2 squared? Yes, I want you guys to keep on repeating that formula as often as possible. The formula for area is the radius squared times pi. So why am I going to be multiplying the radius by itself? Because that's what the formula says to do. 1.2 squared is then multiplied by pi. And to do this exact in terms of pi, 1.2 squared, this is where I need your help. 1.2 squared, Joshua, Dylan. 1.44. So the area is equal to 1.44 pi. Units of measure is inches, and so it's not inches, it's inches squared. 1.44 pi inches. This is exact. No rounding necessary here at all. Now, as it's time for me to approximate it, now is when I actually need to type the whole thing into my calculator. 1.44 pi. I'm typing this into my calculator as we speak, and I get the area is equal to 4.52389, but rounding to the nearest tenth is going to be 4. Because that 2 is not enough to round that up, so 4.5 inches squared. We can also use circles and the area of circles when we are problem solving. So yes, I've got these ones down here, but I have a real life situation This is also very real life to us because 2 years ago, 2 years and 3 days ago, right? Or 2 years and 4 days ago, we actually felt our first earthquake here in Utah. Before, this was just an imaginary problem. Now it feels a very real life one. Yeah, some of you guys did. Most adults did not sleep through it. I was terrified. A certain earthquake was felt by everyone within 50 kilometers of the epicenter. You guys didn't do a good job of that. Remember how you heard my voice just there? You heard my voice, so your voice goes... Let's try that again. An earthquake was felt by everyone within 50 kilometers of the epicenter in every direction. Draw a diagram of that situation first. What does that mean if an earthquake was felt by everyone within 50 kilometers of the epicenter? That means the earthquake is starting right here. That's the epicenter. But it's being felt 50 kilometers in every direction. What is that going to look like? Am I going to feel it 50 kilometers this way? And am I going to feel it 50 kilometers this way? And what about this way too? And this way? And when I go 50 kilometers in every direction, my arrows are continuing to get smaller and smaller. When I go 50 kilometers in every single direction, what does that mean? What do I have when I go 50 kilometers in every direction? Grant? 50 is the radius. That's exactly what that means. What I really have is I've got a circle. And this is a perfectly drawn circle that no one can judge at all. Because it's so perfect. It actually isn't too bad until you get to right here. 50 kilometers in every direction means the area that is feeling it is a circle. So what is the area that felt the earthquake? What are we really being asked to find? The area of this circle that Grant already pointed out has a radius of 50 kilometers. Let's get that done. It doesn't say that we need to do it exact in terms of pi, so I think it's safe to just round this answer. Again, this is the radius. The radius is 50 kilometers. So the area is equal to the radius squared, which is then multiplied by pi. So I have 50 squared times pi. You have calculators. Type that in. See if you can type it in faster than me. And 50 squared pi, I end up with 7,853.98. I think that that is close enough that we can say about 7,854 kilometers squared. Number 5. The area of 5 objects is given. So understand what that means. The area is given. What you need to do is calculate the radius of each object surface to the nearest hundredth of a unit. So here's the smiley face, and I'm not giving you the radius, I'm giving you the full area. We need to use that to then find the radius. Just trust me, I'm going to skip this one. We're going to skip that one. Let's go to this one instead. Area of the base of a plant pot. So the pot is sitting on a base so that the water doesn't leak out. The area of that base is 50.24 inches squared. We need to find the radius. How do we do that? It's just a matter of, number 1, understanding the formula, and number 2, working backwards. So the area, as we have wrote down for every single problem, as we have applied every time, the area is equal to the radius squared times pi. But I tell you what the area is. The area is 50.24. And again, that area is equal to the radius squared times pi. We need to solve this equation. The first thing that I see is r, the radius, is being squared. Okay? And after I see that the radius is being squared, I see it's multiplied by pi. So how am I going to undo that? We undo multiplying by pi by dividing by pi. So again, this might look weird, but we're just dividing by a number. That number is just represented by the symbol pi. Pi divided by itself, anything divided by itself is 1, so that divides out. So in my calculator, I should be typing in 50.24 divided by pi. And I get 15.99188. And that is not the radius, that is equal to the radius square. Now, there's two things that you can do here. There's two things that you can do. One is understand that 15.99 is pretty close to 16. Would you agree? Now, what number, when multiplied by itself, because that's what squared means, is the number multiplied by itself is going to be 16. No talking right now. Just let your brain think. Don't take anyone's thinking away from them. What number multiplied by itself is going to be 16? Raise your hand when you know. You can start going through the numbers. 1 times 1, nope, that's too small. 2 times 2 is 4, nope, that's too small. Keep going through and eventually you'll figure out what number multiplied by itself is equal to 16. What is that number, Cambria? Nope. 8 times 8 is not 16. You made the classic mistake that so many students make. You tried dividing by 2. We can't divide by 2 here. Instead, we have to think what number, when multiplied by itself, is going to give me 16. Do you have it, Bella? What is it? It is 4. 16 is equal to 4 multiplied by itself, or in other words, 4 squared. Therefore, we can then assume that the radius is equal to 4. Now let me tell you something, folks. Because squares are not technically something, or equations that have squares or exponents in them are not something that you should be doing until 8th grade, all of your problems will be able to be done mentally like this. However, you also should know, I'm going to go to a new page here. I want you to recognize, eyes on the screen please, we're switching gears, we're not working on any problems right now, eyes on the screen. I want you to understand a quick little thing about inverses. Okay, inverses are the things, the operations it will undo. For example, if I have this as the operation addition, what is the inverse that will undo addition? Grant? Subtraction. And so what if the operation itself is subtraction? What is the inverse that will undo that? Dylan? Addition. Let's try some harder ones like multiplication. How do I undo multiplication? What would the inverse of multiplication be, Tanner? That one's division. Well, what if the operation itself is division? How do I undo division? Luke? With multiplication. So here's what I want you to see first and foremost. If I'm dividing to solve, what is dividing undoing? It's undoing multiplication. What we have something here is different. We have a square. So some students say, well, we undo a square with division, but that's not true. We undo multiplication with division. So how am I going to undo a square? Talk with your group. Some students already know. Share that knowledge. What is the inverse of square? Squaring something. How do I undo that? Carter.
So it's the, you use a symbol for square root.
Yes. The square root is how we undo a square. What that means is if I have an equation that says 16 is equal to the radius squared, that's when I say to myself, hey, the variable is being squared. How do I undo squaring? We use its inverse and we take the square root. Whatever I do to one side, we do it to the other side. And again, this is weird. We maybe don't understand what's happening, but remember, the reason I specifically chose a square root is specifically to undo the square. So as weird as it looks, this and this, oops, they undo itself. They undo each other. So when I undo it that way, what do I have left? R. What is R equal to? Let's see how we do this in our calculator. We've already done the math in our heads. A number multiplied by itself is equal to 16. That number would have to be 4, but here's how we use the calculator. Again, in your template options, you can see the square root symbol. So you can click on that, and then you can type in 16. The square root of 16 is equal to 4. Another way we can do that, will you please take a look next to the number 4 is our x squared. We've been using that when we've been doing our radius squared, right? What do you see in yellow up above yours? In blue up above mine? It's the square root symbol. So it's that control. If I hit control and x squared, do you see how it automatically chooses the thing that will undo it? And the square root of 16 is 4. So 2 ways that we can use our calculator to do that. Most calculators, even your silly iPhone calculator, should have a square root and a square option. That's also why I prefer Desmo Scientific. It is great and it will definitely give you that option. But the square root of 16 simplified to be 4. Again, please understand that 16 divided by 2 is 8, but that's not what we're doing here. We're undoing a square with the square root. We're not undoing a square with division. So, back to this problem. Another way that I could have done it, just kind of picking up right here. So I'm going to pick up right here and just redo it down here. 15.99188 is equal to r squared. This way we don't have to round too early, and we will still get the same answer, and that's great. But I say, hey, wait a second, r is squared, so I'm going to undo that square by taking the square root, and doing the same thing to both sides keeps it equal and balanced. R squared, and then the square root of that will undo the square, so I'm left with just r. And over here on this side, that's when I can do the square root. I'm going to cheat and I'm going to see if I can just highlight that and put it in. Yep. You see what I did there? I did the square root and then I scrolled up until that was highlighted blue, pressed enter, and it just copied and pasted it down there. Now when I press enter, 3.9989, and again, we're like, oh no, we got something different, right? Except the fact that this whole time we are rounding to the nearest hundredth, and rounding this to the nearest hundredth is going to be 4.00 is the radius. We're just going to go by majority vote here. We need to do a couple more of these problems for practice, but I want to know who wants to do at least one more together. Raise your hands. Okay, who is ready to just work with their groups? Okay, I'm going to let you work with your groups, but I will visit those who had their hands up saying that they want to do one more together. We're going to pause the recording as students work on these. Ready, set, go. Moving on to the next one, the target area is equal to r squared pi. And the area is 153.86, and I know that the area, now I know what the number is, but it's still equal to radius squared times pi. So I need to solve this. I can just see that the radius is squared, and then it's multiplied by pi. And I undo multiplying by pi by dividing by pi. Balancing it by doing the same thing to the other side. And I end up with here, pi divided by pi is just 1, so on the right-hand side I have r squared. And that is equal to, I need some help here, I believe it's 48 something. Dylan, what did you get? 48.97, and there's no other numbers, but that's probably good enough, right? Give me one more number. Do you have it? 975, great. Okay, and now, again, I can say, hey, wait a second, 48.975, that's pretty close to 49, right? And what is a number that when squared, or a number when multiplied by itself, is going to be 49? Sophie? Yeah, that's 7. So that tells me that r is equal to 7. Or, picking up right where I left off, I can also use my calculator. That leaves me with 48.975 is equal to r squared, and I undo r being squared by taking the square root. And whatever I do to one side, I do it to the other side. So I have the square root of 48.975, and I ended up with r is equal to 6.998. Rounded to the nearest hundredth is r is equal to 7.00. Same thing that I did up here, right? Like I said, these problems are going to be problems that you can do without a very fancy, sophisticated calculator. One thing that we need to make sure that we mention here is the area was given to us in inches squared, so the radius is going to be in inches. Up here, the area was given to us in inches squared, so the radius is going to be also in inches, not inches squared, but in inches. All right, students have left, so I am just going to walk through one more of these so that students who are watching the video will have all the experience and practice that they need, and then I will leave the last two for you to do on your own. Here, the area of this circular tile pattern is 78.5 feet squared. Again, I know the area is equal to the radius squared times pi, and the area that's given is 78.5. So, area, which is 78.5, is still equal to the radius squared times pi. R is squared, but then it's multiplied by pi, so I undo multiplying by pi by dividing by pi, and balance it by doing the same thing to the other side. Pi divided by pi divides out, and here I have 78.5 divided by pi, and I get the radius squared is equal to 24.9873. Now I'm going to, let me fix that a little bit. 24.9873 is equal to the radius squared. So again, I can solve it like this, taking the square root of each side, but this rounds up enough that I think it's safe to say, hey, 24.9873 is really close to 25. So the radius squared is equal to 25, and then I can say, well, what number multiplied by itself, that's what r squared means, what number multiplied by itself is going to be 25? And based on that, I can see that the radius is going to be 5. Let's take care of the units. The area was feet squared, so the units here are going to be feet. The radius is 5 feet. But again, being precise and not rounding too early, we can pick up right where we left off here and see that that is 24.9873 is equal to the radius squared, which I will undo that radius squared by taking the square root of each side and typing this into my calculator. I get 4. So remember, this undoes r squared, taking the square root of that undoes, so all I have is just r. R is equal to 4.9987, and 4.9987 rounded to the nearest hundredths place, as it says to do in the problem, is 5.00 feet for the radius. So again, I want to point out we're getting the same thing regardless. Okay, these particular problems have been designed, so it's okay if you don't know about the square root. You can round here and say, oh, I know that this rounds to 25, and a number times itself equaling 25 would have to be the radius is 5. You can also use the square root feature on your calculator and take the square root of each side, and we get the exact same answer. So for these last two, I'm going to pause the recording. I'm going to do all of the work and let you just check your answer. So I want you to pause the recording, do all of your work, and then continue the recording just to check your answer. Only continue past this point in the recording if you've done these last two problems. All right, there's your answers. I showed my work as well as the answers, so you can check your work, see how we're doing these, and I did each one of them both ways that we've talked about doing them. Now let's move on. These next two problems I assign as homework. Especially in the honors class, this is a great way to see that depth of knowledge and get to that deeper level of thinking. There's one circle that has the same numeric value for its circumference and its area. The units are different, but the number itself is going to be the same. It says use any strategy to find it, and it gives a hint the radius is the whole number, which makes it easy to find. So again, what that's saying is the area is equal to the circumference for one and only one circle. I want you to figure out what that circle is. What is the radius of that circle? One last hint that I will give you, remember area is the radius squared times pi. And for this one and only one circle, that is equal to the circumference, which is the radius times 2 times pi. I'm not going to go over anything more. We'll go over this in our next lesson, but I want you to think about that. What is the radius of that circle? There's one and only one circle. that this will work, what is that circle? And then after you do that, then you're ready for number 5. Explain the difference in the units for the circumference and the area for that one circle. So again, the number itself is going to be the same. So the number for the area and the number that we get for the circumference is the same. The units are going to be different. So in number 5, what is the difference in those units? Make sure you do that for homework, and the rest of the homework is these homework section problems. You can see what you got going on there, a lot like what we did in class. So that's it for today. Thanks for watching, and we'll see you next time.